Right, so today we are going to get into right triangle trigonometry. So when I have a right triangle, I have actually three sides. Obviously, there's three sides to any triangle, but when I'm looking at a right triangle, there are specific sides. So these are my opposite side, my adjacent side, and my hypotenuse. So my hypotenuse is always going to be the longest length. And an easy way to find out what the hypotenuse is if you look at where your right angle is, which remember, denoting a right angle is that square. Whatever side is not attached to that square, that's the hypotenuse. The opposite side is the side that is not attached to the angle, and then the adjacent side is the side that is attached to the angle. And the opposite and the adjacent sides are not the hypotenuse. So if I'm looking at this triangle here, if I'm looking at this angle theta down in this corner here, first of all, I like to label my hypotenuse first. My hypotenuse, again, is always the one that is opposite my right angle. So this is my hypotenuse. And then if I'm looking at this angle theta, my opposite side is the side that doesn't touch it. So that is my opposite side there. And then my adjacent side is my side that helps to form that angle. So when we're working with these right triangles, we have 6 specific trigonometric functions. So these are sine, cosine, tangent, cosecant, secant, and cotangent. And then these are the 6 ways that these functions are evaluated. So if I ask for the sine of a specific angle, it's whatever length the opposite side is over the length of the hypotenuse. The cosine is the length of the adjacent side over the hypotenuse. The tangent function is the opposite side over the adjacent side. And an easy way to remember this is SOHCAHTOA. So I have my sine is my opposite over my hypotenuse. My cosine is my adjacent over my hypotenuse, and then tangent is opposite over adjacent. If you remember SOHCAHTOA, then you're easily going to be able to remember all of the 6 functions. Because once we get into cosecant, secant, and cotangent, these are what we call the reciprocal functions. So when I say reciprocal, I mean that we flip the numerator and the denominator. So cosecant is the reciprocal of sine. Cosecant is hypotenuse over the opposite. Secant is the hypotenuse over the adjacent. And then cotangent is the adjacent over the opposite. I want to do one quick example. We're going to get to a lot more when we are in class. But I'm looking now at this example, I'm looking specifically at angle A. So I always like, when I'm solving these problems, I always like to write SOHCAHTOA, so that way I remember what I'm working with. So my sine of A, so I'm looking at my opposite side. My opposite side length here is side BC, and that has a length of 24. And then I am looking at my hypotenuse, which is always my longest side. My longest side here is 25. So the sine of angle A is 24 over 25. Cosine is adjacent over hypotenuse, so my adjacent side is 7, and then like we said, my hypotenuse is 25. So the cosine of angle A is 7 over 25. And then I get to my tangent. Tangent is opposite over adjacent, so we know that my opposite side length is 24, and then my adjacent is 7. So the tangent of angle A is 24 over 7. And then once we get to these 3, cosecant, secant, and cotangent, we can just flip the sine, cosine, and tangent that we already found. So cosecant is the reciprocal of sine, so that is 25 over 24. The secant of A is 25 over 7, and then cotangent is 7 over 24. One important thing that a lot of people mix up is they think that cosecant goes with cosine and secant goes with sine. That's not true. Cosecant is the reciprocal of sine, and secant is the reciprocal of cosine. So that's one thing that you want to make sure that you are keeping straight. And then one other thing with these examples, if you get a fraction like 2 over 4, you always want your final answer to be in simplest form. So if you can reduce the fraction in any way, always make sure that you reduce it. And we have the Pythagorean theorem review. So sometimes you might have a triangle, you might have a right triangle where you're given something like this, where you're not given all three sides. So sometimes you might have to solve for one of the sides. So that's where the Pythagorean theorem comes in. And the Pythagorean theorem says that if I have a right triangle, then a squared plus b squared equals c squared, where c is the hypotenuse of the right triangle and a and b are the legs. The legs are the opposite and the adjacent sides. So if I have a squared plus b squared equals c squared, to find what I'm missing here, first of all, I'm missing my hypotenuse because it's opposite my right angle. So I would plug 6 and 8 into the formula. So I have 6 squared plus 8 squared equals c squared. And then 6 squared is 36, 8 squared is 64, and then that gets me c squared. So I get c squared equals 100, and then if I take the square root of both sides, I get that c equals 10. So that's just a quick example of the Pythagorean theorem. And again, sometimes you might have to solve triangles specifically for missing side length.